At ROB, we have been rebuilding our GNSS station metadata management system, and we call it M3G. So you see for what the abbreviation stands. And in fact, we did these efforts in the frame of the development of the European plate observing system. And there is nothing here about this, but probably at the next workshop you will hear more about what EPOS is all about. And also we will use the system within EUREF. So it will manage station metadata, site logs, site pictures, individual antenna calibrations, and additional information that comes from our GNSS station database. And different to other systems is that it will have to manage the metadata of several networks, for example, DPN, EPOS, or DPN densification. And these networks have different metadata validation rules. Just to give you a very simple example, in some of the networks, it is mandatory to have a DOMS number, and in others not. So we have to have network-dependent rules. So the software will include a GUI for creating, updating, and validating GNSS station metadata. So it's the update of our online sidelog submission tool that we have today, and we'll use GeodesYML as the format for exchanging GNSS station metadata. So what we did in the summer last year, when we had the time to look at GeodesYML, and it was still version 0.3 at that time. So we took our EPN logs and densification logs. So in total, we had about 1,400 station logs, and we tried to map them in GeodesYML. Now it was nice to do it because we saw a lot of advantages of using GeodesYML, and the biggest advantage was that it allows to include so GeodesYML allows to include information that is in our database, but presently does not have a place in the site log. And I am thinking, for example, of a very simple example. It's the Bruyninx stream monument and receiver number. Today it's still 00, but I don't expect it will continue to be 00 forever. So we need a place to have it. The three-character ISO code of the country. And also interesting for us from, again, the EPN side, is that we have the possibility to have the URL with the place where you can find individual antenna calibrations. Although we have the impression, and we are not experts in GeodesYML, I must confess, is that we have the impression that there is just the possibility to have one URL. So if you have an URL pointing to a site picture, we have the impression that you cannot, in addition, have an URL pointing to an individual calibration. But these are details. Geoscience Australia has a forum, and we can discuss all the details there. We also have the possibility to include information about real-time data stream details and so on. So we had a couple of difficulties, and I will not go through all the details because the main conclusion is that most of them have been resolved in the new version. I already mentioned it. It is a bit complex as a non-expert user, so I must confess we spent a bit of time looking at everything. So, as I said, most of issues have been resolved with the version 0.4. We didn't have time to look at all the details, so we are wondering still at the moment if we can include information on what kind of Bruyninx data are distributed. Is the station doing Bruyninx 2, Bruyninx 3? Do they do hourly and daily? We think it would be nice to have it included. Is there an embargo time on the data? You will say for the IGS we don't need it, but this is a standard that will not only be used in the IGS. It will also be used, for example, in other networks like EPOS, and there have embargo times on data sometimes. Also licensing info, again, maybe not of interest to the IGS, but it is getting more and more important in other networks. The OI information and these kind of things. At the moment, we still have some difficulties to map the site owner and contact information from the site log to GeodesYML, and this is of course important for us from the network coordinator point of view, because you need to know, of course, who to contact when the station has a problem, but this will be solved, I am sure. So as I already mentioned in the beginning, we are faced with the situation that we will have to apply in the future different validation rules for different networks. And this requires from us to implement a two-step validation of station metadata. So we will use the XML schema definition of GeodesYML to focus on the syntax validation and the format of the field content. And then we will do a second step where we will apply the network dependent validation rules, for example, the mandatory DOMS number, or the fact that an antenna can only be accepted when it has type mean calibration, which is the case of the IGS, but for example in the EPN, you accept also individual antenna calibrations. So from the point of view of the observatory, we need an XSD that does not define what is mandatory or not, except for some key elements. So we need a station name, for example. On the other hand, we need an XSD with strict rules to allow format verification of the filled-in elements. So for example, in the present XSD, and again, I am sure this will be solved, the station 4 character ID is mandatory, but you can insert even a blank or 2 or 3 characters. DOMS number is again mandatory, but you can insert any string. And the antenna receiver section does not seem to be mandatory. So concerning the machine-to-machine exchange of GNSS metadata, so we will be having a system for uploading and validating metadata, which will be distributed through GeoDesDML format to EPOS, and maybe in the future to IGS and other networks. We of course have our own databases at the local level, so this is quite transparent how the link is done between the validation and these databases. We will implement WSDL for EPOS, and this is a standard that is independent of the chair server applications.